welcome to the Journey Shake Chem. Well, please do the warm-up questions as quickly as possible so we can move on to the lab. Number 1 asks, what is a hydrogen bond, or what is hydrogen bonding? It is a very special kind of bonding that occurs between hydrogen and nitrogen, oxygen, and fluorine, because there's a greater attraction because those atoms have a higher electronegativity, and therefore there's a greater attraction than what would normally be expected. It's very important for number 2. The density of ice is less than the density of water because of the hydrogen bonding sets up spaces in the crystal lattice, and those spaces cause the density of ice to be less than that of water. As the ice melts, those spaces collapse and the molecules move closer together and water becomes more dense. And those are the changes that happen in the density of water as it changes from ice to water. All right, we'll see you over there in the lab. Now, this is a vacuum pump, and we are going to suck all the gases out of this bell jar. And when we do that, we are removing the molecules with the highest kinetic energy. Gases have higher kinetic energy than liquid or solid. Therefore, by removing the high kinetic energy, the low kinetic energy is left behind and the temperature will drop because we've removed the high kinetic energy. The higher the kinetic energy, the faster the molecules are moving, and they're colliding with the walls of this container. And by removing the high kinetic energy, low kinetic energy is left behind and the temperature goes down. Now, as that happens, we're going to approach water's triple point, and it's 0.6 kPa. You can look on the chart for the lab, and a very low temperature. Now, I'm going to turn this on, and I can feel the air coming out of the container. And I can already see that the ice is bubbling. And when I see the bubbles, I know that it's boiling. Therefore, I have a gas from the boiling, I have a liquid and the solid. I have all three things at the same time. And it's icy water. It's not hot. It does not require heat in order to boil. It is a temperature and pressure relationship. Therefore, when I see those bubbles, I see that it is boiling. Now, on the worksheet that you have to do for this lab, it asks for the changes as you move from right to left or left to right. And those changes should be like melting, freezing, boiling, condensation, not phase changes. So you need to make sure that you answer the questions carefully. And that was quick, wasn't it? That was some fun, and that's just so exciting. I never knew that you could it wasn't hot. So there you go. Thanks for being here, and we'll see you tomorrow.